this is the statement of the comparison test. Everyone look in the box here. So we have subscript summation A subscript K and summation B subscript K. So we have two series with the all positive terms. So the statement say that if you have the inequality 0 less than A subscript K less than BK here, and you know that the BK is convergent, so then you can make a conclusion that the summation A subscript K is also convergent. That is the first statement. The second statement is if you have BK less than AK and you know that the BK diverge, so you can conclude that summation AK diverge. So this is how it works. So if you want to just save your space to memorize, so you can imagine that when you can think of AK, this is the series that you want to know, series that you want to know it is convergent or divergent. This is the one that you want to know. So summation BK, this is the one that you already knew the pattern. So basically A subscript K gonna be the one that you want to know it is convergent or divergent. BK is going to be the one that you already know it is convergent or divergent. And if you face the first case, it's gonna be that AK, this is the one that you want to know, less than BK, this is the one you already know. So if you know that BK converge, so AK converge. It means that if you can find something that is bigger than the term that you want, so and that term that is bigger is convergent, so you can conclude that it is convergent. Does it make sense? And the case that I highlight in orange, this is the one that the thing that you want to know, it's outside here. The thing that you already knew it's inside here. So if this thing BK here, some BK diverge, so AK gonna be divergent as well. All right, and this is called the limit. This is called the comparison test. The series that you want to the BK here, we're gonna go to example pretty soon, but the series that I say you already know the pattern, this is the one that we use a lot. We're gonna use the P series, we use a lot, and we also use geometric series a lot. So remember when we learn P series, so we have summation 1 over K to the P. This is the series called P series. K start from 1 to infinity. So this one gonna be convergent. It is convergent when P is bigger than 1, and it is divergent when P less than or equal to 1. So this is the P series that we learned from last time. So we will use this thing a lot. And also the geometric series, you have sum A times R to the n minus 1, whatever, or K minus 1. K start from 1 to infinity. Whatever you have here could be K, just K or K minus 1, it doesn't matter, but it's geometric series because you multiply R on each term. This is going to be convergent, converge. This is when absolute R less than 1. If the common ratio less than 1, it is convergent, and divergent when absolute R bigger than or equal to 1. So this is going to be two series that you're going to use a lot to compare with the thing you know. Let me give you an example. For example, if you want to, you already know that we're gonna just do a quick example here. So example, if you recall from last time, we know that summation of everyone, sum of 1 over n to the 3 over 2, let's say K, this class we use K to the 3 over 2, k start from 1 to infinity. This one convergent or divergent. So you can see that this one is actually convergent. This is by P series. It is a P series, right? By P series P equal to 3 over 2. This is actually a convergent one, because we know that if P greater than 1, this is convergent. So this is P series P equal to 3 over 2, which is bigger than 1, so it is convergent. Now you can compare this thing with something else. For example, you can try to look at the, hold on, I'll try to find the space. Okay, here. So if you have n cube and n cube plus 2, for example, and then this, which one is bigger? For sure n cube plus 2 is the bigger one, right? Here n cube plus 2 is going to be the bigger one, because you plus 2 on the right hand side. And if you take the square root, it's gonna be the same. So square root n cube here and square root n cube plus 2, they're gonna be okay, this inequality. And then if you do the cross multiply, so it's gonna be 1 over square root n cube plus 2 less than 1 over square root n cube. Does it make sense? You just cross multiply it. And then now you can imagine that on the left hand side here, this is your a subscript. This is your a. On the right hand side, this is your b. Right? And then you have a subscript n or less than b subscript n. And you already know that on the right hand side here, this is the P series, because this is the same thing with 1 over n to the 3 over 2, which gonna match with the pattern of the P series here. So if you have this inequality, and you also know that the right hand side here, if you take the summation, it's gonna be convergent, right, by the P series. So you can apply the comparison test. This is the idea of the comparison test. So we're gonna have, I think, 4 questions to practice the comparison test. So let's do it together. So we're gonna start from ready. So we're gonna start from example 3 here. So this is the idea of the comparison test. So I spent 10 minutes talking about the idea first. So example 3, using the comparison test. So can you conclude that the series converge or diverge for this example, part A, B, C, and D. So let's start by part A. You have sine square k over k cube. Summation k start from 1 to infinity. How do you use the comparison test here? So you can see that your sine k here. I told you before that sine k gonna be between -1 and 1, right? No matter what the value of k is. So sine gonna be on between -1 and 1. This is we learn all the time. That means when you have sine square k, this is going to be bigger than 0 and less than 1, because you square it. So it's gonna be between 0 and 1. And then now if you start from sine square k and you divide it by k cube. So when you divide it by k cube, you have to do it all the way from the left to the right hand side. So it's gonna be that and that. So which means on the left hand side you have okay. Here this is sine k between -1 and 1, right? But when you square it, so it's gonna be positive anyway. So it's gonna be positive. So this can be -1 square. No, it's gonna be positive. So sine between -1 and 1. But when you square it, so it's gonna be something like you the minimum one gonna be 0, right? Because the square you cannot get something below 0. This is the pattern of the square thing. And then sine square between 0 and 1, and then you divided everything by k. And then everyone can see what I highlight here. The one that I highlight in light blue here. So you can treat this thing as your A subscript K. This is the series that you want to know the pattern. But the BK here, this is the one that you don't know. You already know, right? But AK is the one that you don't know yet. So now you consider summation B subscript K. So summation B subscript K is 1 over K cube. K start from 1 to infinity. This series is actually convergent, right? Because this is the P series. Because it is a P series with P equal to 3, bigger than 1. So that means this is actually convergent. What you discover here is you found that A sub K less than B sub K, and you know that summation B sub K is also convergent, which means by the comparison test, you can conclude that summation of psi square K over K cube, it is actually convergent as well, because you know you have something less than this thing, all the term for all K, and then the thing that you have on the upper bound is convergent already, so this thing should be convergent as well. This is by the comparison test. The hardest thing about the comparison test is you need to find an inequality to start with. So for this one, you start with psi K between -1 and 1. Well, we're gonna have more example, and then you're gonna see more pattern that you can start from something else as well. Sounds good? Question on this one. This is like the
It's similar to the squeeze theorem, right?
kinda. Yeah, I mean like, but the squeeze theorem you need both left hand side and right hand side to be the same, so you can conclude that in the middle you're gonna be the same. But this one you only need one side. If it is on the upper bound on the right hand side, you need a convergent series. If it is on the lower side, on the left hand side, you actually need a divergent series. Alright, so let's do part B here. What if I have summation of arctan K over K? So how do you find the inequality of arctan K? Arctan K is between what and what? Yeah, pi over 2 on the top, and here it's negative pi over 2, right? This is for all K. But now you start from K equal to 1. Can you make it the bound smaller if K start from 1? What is arctan 1? It's pi over 4, right?
Yes.
When you draw the graph of arctan, everyone think that way. When you draw the graph of arctan, it's gonna be the graph in red. So this is Y. This is X. Yeah, for sure we know that it's gonna start from the boundary is negative pi over 2 to pi over 2. Yes, we know that. But think that if we start from K equal to 1 and so on. So from 1 and so on, it's only the part that I highlight in green, right? Just only that part. So can we say that when K is bigger than 1, so we're gonna say arctan K is in between pi over 4 to pi over 2. This is when K is bigger than or equal to 1. Agree? Because you know when K is equal to 1, the value of arctan is pi over 4 already. So it should be between pi over 4 to pi over 2 when K is bigger than 1. Now you have the inequality to start with. So you make it, the middle term should be the same with the question. So we're gonna just start from arctan K over K here. So we do over K because it's gonna be the same thing with the question. And then it's gonna be pi over 2K and greater than pi over 4K. So what is next? How do you use the comparison test? So the thing that you have here, arctan K over K is A subscript K. Now what is your B sub K here? So think this way first, don't copy yet. If you box this one, you can have one inequality, right? Or you can box this one, you can have another inequality. But let's start from if you use this one, what happened? So if you use this one, it means you already have AK here less than BK. So you have to figure out the BK here gonna be convergent or divergent, right? If you think that way, it's gonna be sum pi over 2k. And if you pull out pi over 2, it's gonna be pi over 2 sum 1 over k. This is convergent or divergent?
Divergent.
This is divergent by the P series or harmonic series that we learned last time. 1 over k is gonna be divergent. So it means if you take summation bk, it is actually divergent. But you cannot conclude anything, right? Because this term divergent doesn't give you anything because you cannot conclude anything about AK. Does it make sense? So that's why this one does not work. So you have to look at on the left hand side instead. And then this thing, when you take sum pi over 4k, yeah, this one's gonna be divergent, and that means this term gonna be divergent as well. Okay. So we're gonna pick this one to be our BK. Okay, and then now let's take a look at summation BK here. This is going to be summation of pi over 4k, and then you have pi over 4 times summation of 1 over k. K start from 1 to infinity, and this is actually diverge. You can say harmonic series, or you can say P series where P equal to 1. Same thing. I say harmonic series 1 over k. So it's divergent. Then when you make a conclusion, it means that by the comparison test, the given series is divergent. Is that okay? The thing that we learned from this example is that even you have inequality, sometimes it does not work. Like sometimes you have AK less than this one, but sometimes the boundary that you have here or the term that you have here, it is actually divergent, so it make no conclusion for you. So it is not easy to apply the comparison test. You have to find the exact inequality to use it. So this is not an easy one to use unless you are good at the inequality, so you can just make the bound to be like perfect, and then you can apply the comparison test. Okay. Things will get better after you do exercise in section 8.5. All right, we're gonna do 2 more. Which step? This one? To which one? Oh, why cannot use this one? Yeah, because if you use this one, so it means your summation of pi over 2k, this is also divergent, right? But when you have something less than something, and then you know that the upper bound here is divergent, you make no conclusion. Because from the theory, there is no conclusion about that thing. So let's take a look at the theorem again. So it says that if you have this one, AK less than BK, the top one here must be convergent, then you can make a conclusion that it is convergent. Does it make sense? In terms of the intuition, you can think that when the BK converge here, summation BK convert, it means that this one gonna convert to some number L. When it's convert to some number L, A sub k gonna convert, summation is gonna convert to some number between 0 and L as well, right? But if you can say that some bk is divergent, it means this gonna go to infinity. So A sub k could be infinity or could be any number as well. So the upper bound here cannot be divergent. To make a conclusion, it must be convergent. This is why we say that, oh, this way we cannot use that one. We have to use the left hand side here. Okay. All right. Let's do two more, and then you're gonna see more example about the comparison test. Let's do the part C here.
It's important to make the right. If we compare BK on the right side, it should be converged to be converged.
I mean, if you can find another bound that give you a convergent series, that is fine.
I want to use the right hand. It should be converged to be conclusive, right?
No, I mean this series divergent. I mean it's.
I mean, if I can find the right hand side to be converged, it can be concluded.
Yeah.
But then,
Well, that's what I just said, that if you can find any boundary here that is better than this one, if you can find it,
they can conclude it.
yeah, and then you say that this is actually convergent, so it's gonna be the middle one gonna be convergent as well. But for this question, no way that you can find the convergent series to bound here. All right. All right, next one. So we're gonna do part C here. Let's start by, if you have 1 over 3 to the k plus 1, k start from 1 to infinity. How do you do the comparison test here? Of course, this one should compare with 1 over 3 to the k, because it's look pretty simple that way. So let's start from 3 to the k plus 1. This is actually bigger than 3 to the k, always, right? And then you swap it, so it's gonna be 1 over 3 to the k less than or greater than. I will do this one then. I will do just cross multiply first. Would you agree this? I just do the cross multiply here. And then now you have the inequality already. That, take a look at this one. You have the inequality already. So 1 over 3 to the k bigger than 1 over 3 to the k plus 1 bigger than 0. You can think that this one is your a subscript k. This one is your b subscript k, right? We want to know that a subscript k, summation a sub k is convergent or not. So we can take a look at b sub k first, and summation b subscript k. This is actually summation of 1 over 3 to the k. Convergent or divergent, this one? 1 over 3 to the k. It is summation 1 over 3 to the k. K start from 1 to infinity. Convergent or divergent?
Convergent is geometric series.
Okay, it is convergent, because this is actually geometric series with r equal to 1/3. That means this series is convergent, and you know that the upper part or the boundary is actually convergent, which means if you take a look at the series that you want, summation 1 over 3 to the k plus 1, this must be convergent as well. By the comparison test. Sounds good? You need to be lucky enough that the BK part here is actually convergent. Well, I mean, if you if you bound with something that is divergent, no conclusion. Yeah, I mean, like, you have to pick something else, because if you want to use a comparison test, the thing that you want to test, you have something bound on this one, this thing must be convergent in order to make the conclusion. Does it make sense? Okay, next one. Sounds good already? Alright, so part D. What about log k over k? How do you bound it? K start from 1 to infinity. So we're gonna start by looking at the function log x or log k. What is the log k here?
Okay.
So y x, if you draw a graph of log, logarithm gonna part when x equal to 1, y equal to 0, right? And when x equal to e, y equal to 1. Would you agree? When x equal to e, y equal to 1. Can we say that log k bigger than 1? You can do it when x is bigger than e, right? If x is bigger than e, log k gonna be bigger than 1. Make sense? So we're gonna say when x bigger than e, we have that, oops, I'll delete it. When x is bigger than e, we have that summation, not summation, log k. I'm not going to use x, I use k. So when k is bigger than e, log k bigger than 1. Okay, everyone agree? So if k is bigger than e, so log k bigger than 1. But e is not a good number because e is 2.71 something. Can we say 3 instead? When k is bigger than 3, so log k bigger than 1, because I am going to care only the part that bigger than 3, so that's fine. So I have log k bigger than 1, and then now log k over k gonna be bigger than 1 over k. Make sense? And then that's greater than 0, and now you can have this thing. This is the thing that you want as your AK. This thing, this is your BK. Okay. And what is the summation BK? This is one summation of 1 over k. K start from 1 to infinity. And this is divergent, right? By the harmonic series or the P series as well. Which mean a subscript k, when you take the limit, not limit, take the series of a subscript k, this is actually divergent as well, divergent as well by the comparison test.
คือมันเคมากกว่าหนึ่งได้ใช่ไหมไม่มันคือมันคือมากกว่า e อ่ะมันก็มากกว่าหนึ่งยังได้เคมากกว่า3มันก็มากกว่า1อยู่ดี
Okay, so the subtle point here is that some of you gonna have a hard time to think about this inequality. It is true when k is bigger than 3. So which means actually the conclusion gonna be k start from 3 to infinity. But you can add more 2 terms, just 2 terms more, k equal to 1 and k equal to 2. So the pattern of convergence gonna be the same, right? Technically, okay, everyone, technically when you do this one, so you have to say k start from 3, 3, and 3, right? Because you do k equal to 3, k bigger than or equal to 3, right? So it's gonna be you choose start from k equal to 3 if you want to be perfect, correctly, so you have to be start from k equal to 3. But of course if it is divergent when k start from 3 to infinity, k start from 1 to infinity gonna be divergent as well, because this is actually a1 plus a2 and then plus summation a subscript k, k start from 3 to infinity, so this is also actually divergent. No matter where you start, but we care about the behavior on the tail for the series, right? So we don't care the first the second term, so fine. I mean, you can start from k equal to something when you do anything for the comparison test. Sounds good? All right, any question on part D? This is not easy one, but you know, it's the one that good to know that log k you can comparison with 1 here. And also sometimes you're gonna need on the right hand side that log k less than k as well. Sometimes you need it because you can make a conclusion that if you have the function y equal to x, the one that I draw the dash line here, y equal to x gonna be always above the log x. So actually k is also bigger than log k. If you need it, sometimes you can use it. Because sometimes when you want to make a conclusion on the convergent series, you need k bigger than log k. Right? I mean, if I have log k over k to the 10 power, so you need k bigger than log k, and then you divided everything by k to the 10, and that's gonna be the limit the convergent series. All right, so that is the comparison test. So as I told you, this is not the easy one to do because you have to start from the inequality. All right. We're gonna switch from the hard one, comparison test, to the easy one, limit comparison test. This is the easy one compared to the previous one. Let's try to do the easy one here. All right, the limit comparison test. For this one, you're gonna use it a lot when you see the, well, when you see example, you're gonna see that it's a lot easier to use. So the limit comparison test here, we're gonna just start from, you have series AK and BK as well as before. So the AK gonna be the thing that, again, this is the thing that you want to know. It's gonna be the summation AK. You already know it's gonna be BK. You already knew it. So the thing that you already know it's gonna be P series. It's gonna be geometric. You already know it, and you make the ratio between AK and BK. If you make the ratio between an AK and BK, and you get some number L. If the number L is bigger than 0 and less than infinity, then A subscript K and B subscript K, when you make a series, they're gonna be both diverge or both converge, but they're gonna just have the same pattern. Imagine this way, like if you have A subscript K over B subscript K, the limit go to L. What does it mean in your life? It means that when the number is big, A subscript K over B subscript K is approximately L, because it's gonna go to L. And that means A subscript K gonna be approximately L times BK. And that means when you take the series, sum AK, it should be about the same as sum LBK. And that means if you pull out L on the right hand side, it should be the case that sum AK is approximately L times sum BK. So if you have this case, so it must be the case that if AK converge, BK converge as well, because they have the same pattern, right? Because at the infinity, just by the multiplication constant L, so it's gonna be, yeah, I mean, if the term that I highlight in yellow convergent, so the term that in yellow on the right hand side must be convergent as well. The same thing with divergent. So this is what we're gonna use for the limit comparison test. All right, let's do example here. So we're gonna skip this two case. We're gonna come back later if we need, but we're gonna skip for now because this is the one that you're gonna use a lot for the limit comparison test. The one that I skip, if we need it, we're gonna come back later. But mostly when we use the limit comparison test, we're gonna use the statement that I highlight in light blue. This is the one that we need. Okay, so example 4. Let's practice how to do the limit comparison test here. So suppose I have 1 over 2 to the k minus 1. K start from 1 to infinity. What would you do? Some of you may think that, Ajahn, why don't we use the comparison test? Well, you can try comparison test. Don't copy yet, but let's suppose that I want to try the comparison test. So it's gonna be 2 to the k, right? Bigger than 2 to the k minus 1. If I want to try the limit comparison test, just comparison test, it's gonna be 1 over 2 to the k minus 1 bigger than 1 over 2 to the k, right? And then on the right hand side here, if you take a look at sum 1 over 2k, this is actually convergent, but your ak is here bigger than something that is convergent. No conclusion, because you need this one to be divergent to say that this series is divergent. Does it make sense?
That makes sense.
But so comparison does not work for this one because it will not go well as we need. So we don't need the comparison test here. But what we're gonna need is we're gonna need the limit comparison test. So what we're gonna do here is, everyone take a look at this question, because we're gonna just let ak to be 1 over 2 to the k minus 1. And then we're gonna start by pick the bk that is smart enough. So we're gonna pick bk to be 1 over 2 to the k, similar to ak, similar. And then we take limit of a subscript k over b subscript k. Okay, because the question say you should take limit here, and if you get some number L, that means A, K, and BK gonna goes to the same pattern. So this one gonna be limit K start A subscript K is 1 over 2 to the K minus 1. B subscript K is 1 over 2 to the K. Simplify it, so you're gonna get limit 2 to the K over 2 to the K minus 1. And then simplify it one more time. So you're gonna get limit 1 over 1 minus 1 to the 2k. Right, so just simplify one more time. So now you get 1 minus 1 over 0, 1 minus 0 here, because this 1 over 2k gonna go to 0, where k go to infinity. So actually the limit is 1. And that is the number that is bigger than 0. The limit is 1. So what does it mean when limit is equal to 1? It means sum ak and sum bk gonna have the same pattern. The conclusion is sum ak and sum bk have the same pattern of convergence. So you only need to know, if you want to know that AK convergent is divergent, you can take a look at BK. So the BK here, convergent or divergent here, it must be convergent, right, by the geometric series. Sum BK is the sum 1 over 2 to the K. This is actually convergent by the geometric series. Make sense? And because it is r greater r equal to 1/2, and when you know that the sum bk is convergent, you can conclude that. Then we can conclude that summation of a subscript k, which is 1 over 2 to the k minus 1, is convergent as well. Because bk is convergent, ak must be convergent as well. All right, this is actually the solution for this question. So the series convergent, you can do it by limit comparison test. All right. Next one. I'll let you jot down for a minute and then, yeah, today we should finish the limit comparison test. And then, yeah, next week it's gonna be alternative series, alternating series. And then that will be all for the series, which you should be happy after that. Happy that the series is gone like next week. All right, we're gonna be, okay, we have 45 minutes left. Okay, but it's okay. We have 3 more examples, which is good. 1, 2, and 3. Yeah. Okay. So example 4. Let's start for part B. This is the one that I always put on the exam, and I mean like everyone put this one on the exam, so you should start it. This is a question that you always use the limit comparison test for this type of question. So summation k from 1 to infinity, 2k to the 4th power minus 2k square plus 1 over 3k to the 6th minus 1. So how do we do the limit comparison test? All right, so let's take a look. The top part you have k to the 4th power. The bottom part you have k to the 6th power. So the idea is we're gonna try to pick the bk so that the highest degree on the top and highest degree on the bottom match. So here we're gonna let ak to be 2k to the 4th power minus 2k square plus 1 over 3k to the 6th power minus 1. This is a subscript k, okay? And then we're gonna pick bk to be 1 over k square. You're gonna see in a minute why I pick 1 over k square. And then after that, I take the limit of a subscript k over b subscript k, where k go to infinity. This is the limit comparison test. You have to take a look at this one. And then it's gonna be limit k go to infinity. The top part gonna be 2k to the 4th power minus 2k square plus 1 over 3k to the 6th minus 1 over bk gonna be 1 over k square here. And then now you just simplify it. So it's gonna be limit k go to infinity. So you move k square to the top. So it's gonna be k square times 2k to the 4th power minus 2k square plus 1 over 3k to the 6th power minus 1, right? You just flip k square to the top part. And then now you pull out k to the 6th power. So it's gonna be limit k go to infinity. You pull out k to the k square, keep it there. And then you pull out k to the 4th power. You're gonna get 2 minus 2 over k square, and then plus 1 over k to the 4th power, and then the bottom part you have k to the 6th power, and then 3 minus 1 over k to the 6th power. Just the same technique as you learned before when you learn limit, and then you cancel, so k to the 6th, they are gone. And then now you have the limit is 2/3, which is bigger than 0, right? So by the limit comparison test, a subscript k and b subscript k gonna goes to the same thing, converge together or diverge together, which mean here if you have the pattern of sum bk, ak gonna be the same. So sum bk here, sum 1 over k square here, this is actually convergent by the p series. P equal to 2. So sum bk convergent, which means sum ak must be convergent as well. Sum ak is convergent as well by the limit comparison test. Okay, I'll let you jot down and I'll explain more.
How do we know that BK is 1 over K squared?
Mm-hmm.
How do we know?
How do we know that BK is equal to 1 over K squared? Can anyone explain? Because the thing that we're gonna, this is the technique that you should learn from this question, that every time when you see that the highest degree is unbalanced, 4 and 6 here, we're gonna pick any BK that make it balanced. Because we have 4 here, we have 6 here. I observe that this should be 4 plus 2 equal to 6. Why do I need to be the same here? Because if I have the same thing here, so I'm gonna have k to the 6 and k to the 6, and then they cancel out. So you can answer the limit here by just looking at the coefficients. And then once you have this thing, because I mean, like, if you pick 1 over k to the p, it doesn't matter, you know the pattern of this thing already by the p series. Does it make sense? So let me try another one. So if I change this thing to 3 k to the 7 minus 1, you're gonna do the same thing, but you're gonna pick this thing to be k cubed, and the answer gonna be convergent as well, because this thing is convergent, p equal to 3. Does it make sense? Anyone agree? Everyone? Anyone wanna just make a comment or something? Okay, let's try to make sure that you understand this one. So what if I have summation n to the 5th power plus 1 over 6 n to the 6 minus n plus 10. Let's say, let's use k. 1 second. K to the 5th power plus 15, for example, over 6k to the 6th power minus k plus 10. K start from 2 to infinity. So let's suppose that you have this one. You have to use a limit comparison test, right? Because you can see that here and here the highest degree is unbalanced, and then you can use a limit comparison test. So you can say this thing gonna be your AK. So your BK should be, Celine, what is your BK here? 1 over K, right? He's smart enough to say 1 over K. And then, yeah, Porn Puvit. And then, what is going to be your answer here? Convergent or divergent? Convergent or divergent? So you have to take a look at BK, right? Because when you have this question, you have AK here already. You have BK here. This is a good move because you pick 1 over K, and then once you pick 1 over K, you can think that limit AK over BK. When you take the limit of this one, it should be limit K to the 5th power plus 15 over 6K to the 6 minus K plus 10. But you do 1 over K here, so you have K on the top as well. So actually, at the end, the limit here should be 1 over 6, right? Which is greater than 0. And A sub K and B sub K gonna just have the same pattern of convergence. And that means you can take a look at the pattern of convergence by looking at the BK. This one is divergent or convergent? One more time. What, divergent or convergent? 1 over K. Divergent, right? This is divergent, not convergent, everyone. This is divergent, which means this is actually the answer is this is divergent as well. Make sense? Shouldn't be hard for engineering students. Shouldn't be hard for engineering students. I feel like limit comparison test is much easier compared to comparison test because the technique is pretty clear what you have to do. Good. Well, if you are not okay, so let's try another one, part C. What about 1 over 2 to the 2k minus square root k? So you're gonna pick a subscript k, this one. What is your bk then? Should be 1 over k, right? Because this is 1 over k. Well, how do I know that it's gonna be 1 over k, everyone? So take a look. The top part you have no k. The bottom part you have 2k and square root k here. This is actually the highest degree on the bottom is just k. So you're gonna pick bk to be 1 over k here. And then now limit a subscript k over b subscript k. This is going to be, okay, delete this one. So the limit here gonna be 1 over 2k minus square root k here, but because you pick bk to be 1 over k, gonna flip it back to the top and then you get that. Make sense? And then now you just simplify more, so you're gonna get 1 over 2 minus 1 over square root k. And then the limit is 1/2, which is bigger than 0, which means a sub k and b sub k, they're gonna go to the same thing, so convergent together or divergent together. But bk that you pick here, sum bk is actually sum 1 over k. This is actually divergent. This is by the harmonic series or the p series with p equal to 1, the same thing. So the answer is sum ak is also convergent. Oh, sorry, divergent. Yeah, divergent. K start from 1 to infinity. Make sense? This is how you apply the limit comparison test. Trying to pick bk that make the limit to be easily computable, and then you hope for the limit that you get something bigger than 0, and then it's gonna be divergent anyway. This one is much easier compared to something else. So if you want to use the integral test, it means you have to define fx equal to 1 over 2x minus square root x, and then you have to integrate 1 over 2x minus square root x start from 1 to infinity dx. It's much more harder if you use the integral test. You can see that the limit comparison test is easy one when you see the polynomial over polynomial. You can find any bk that make the limit to be easy to compute, and then that's all you need for this one. Make sense? All right, there's gonna be a question like this for sure on the exam for sure, like the midterm one. You're gonna see something like that, and then you need to pick the bk that smart enough so you can compute ak bk easily, and then limit here, and then you make a conclusion. All right, that's part B and C. All right, the last one for today. This is super hard one. This is should be the A level question, because it is a tricky one. So if you have log k over k square, k start from 1 to infinity. So let's think how would you do it. Check this series, convergent and divergent for this one. So if I don't tell you beforehand that this is the limit comparison test, you can think that the first way that we learn for this class to say that the series is convergent or divergent, you can think, can you find Sn? Because you're going to use telescopic series. But seems like it is impossible to do the Sn thing, right? Yeah. Well, if it is log k over k square here, possible to do it, because you can use the property of log. But here k square is outside logarithm. So the telescopic series seem to be hopeless. No. And then geometric series, is it geometric series? No geometric series because you have logarithm here. No. What else? Can you use the divergence test? So the divergence test, if the limit is not equal to 0, so you can make a conclusion. So what if I do it? So I expand the domain to real number, and then if I take the limit, I want to know if the limit of this thing equal to 0. What is it? So I mean, if the limit of a subscript n is not equal to 0, the series is divergent. So it's gonna be differentiate log x, so you get 1 over x. This thing you get 2x. Right? This is the L'Hopital rule, and then doesn't give you a good thing. So it's actually 0 for the limit, which means the divergence test cannot be applied as well because you take limit an already, but limit an is 0. So no way that you can use the divergence test. So telescopic fail, geometric series fail, divergence test fail. So one thing that you can use always is integral test. But integral test, you have to integrate log x over x squared dx from 1 to infinity. In order to use the integral test, we want to avoid it because integral test is like the hard one because we don't want to integrate. And we also need to check, yes, the function is decreasing or not. It's like too much work to do the integral test for now, so we don't want to do the integral test. So possibly you can do the ratio test or root test as well. I mean, if you want to, but the ratio test, you have to do limit ak plus 1 over ak, k go to infinity, and you hope to get something cancellation. But if you do that, it's gonna be log k plus 1 over k plus 1 square plus k square over log k. But I'm pretty sure that if you do take limit of this one, the limit gonna be go to 1, and then it's gonna be no conclusion for the ratio test. So ratio test will not be good for this one. The same thing with root test. Root test, you have to do log k over k square, and then you do power 1 over k, which is make the term more complicated. So how do you know it's go to something? No, you don't know it. So which mean the ratio test and root test, it is not a good way to do it as well. So comparison test and limit comparison test is the one that you can use for this one. So let's start by the because this question is about the limit comparison test. Let's see how hard it is. We're gonna pick here to be a subscript k. We need bk. That is good enough. Because the top term is log k, so we don't know how fast it go compared to the k square. So maybe you have to pick so many choices. So we're gonna start by picking no guarantee that this one gonna work, but we're gonna start by picking bk over equal to 1 over k square first, because I see k square here. Maybe you're gonna get some cancellation. So you're gonna have log k over k square. But when you do bk equal to 1 over k square gonna just go up here, okay? And then you make the cancellation, pop, and then you get plus infinity. Not what we want, right? We just want some number that is bigger than 0, that's smarter that way. This one, it means k square too much. We're not going to do it. Let's do something smaller. 1 over k. Maybe 1 over k gonna work, because we just want something that let you just k, for example. So it's gonna cancel, and then you get 1k left here, and then you have limit log k over k. K start k go to infinity. If you do the L'Hopital rule, limit log k is 1 over k. Differentiate the top part and the bottom part, 0. Which means for the bk now, you feel like if you pick 2, not work, 1 not work. How do we do next? So 2 not working, 1 not work. So what we're gonna do is we're gonna pick something in between 1 and 2. So let's start by k equal to 1, like k 3/2. Just make it halfway, 1.5. So it's gonna be limit log k and then over k square, and then now because you pick bk to be 1 to the k power 3/2, it's gonna be k 3/2 here, and then you make the cancellation, so it's gonna be limit log k over k to the 1/2 here, right? Because k to the 3/2 gonna cancel with k square over there, and then now the L'Hopital rule, just take the limit x go to infinity. So because this is now indeterminate form, infinity over infinity, so if you extend the domain and then you can do the L'Hopital rule, it's gonna be log x over x to the 1/2, and then you differentiate log x, you get 1 over x. You differentiate x to the 1/2, so you get 1 over 2 square root x. It is limit 2 over x to square root x over x, right? It is actually limit 2 over square root x